Yes, morning class. Hope my screen is audible and my voice is audible
Good
and
morning, sir.
yeah, morning.
Yes, sir, you are audible.
And screen is visible.
Yes, sir.
Okay. So I think we were discussing in the previous class that happened with us. Bayesian networks we were discussing, and it will take one or two lectures to complete it. So in the Bayesian networks, we were previously discussing this CPTs, that is conditional probability tables we were discussing. And one example also we discussed. We saw that in conditional probability tables, they have the chances to become very large if the parents, if the node, if the node can have many parents, fine, and or if the parents can have so many values, fine. So we saw that with the help of an example. We tried to make CPTs for, if you might remember, we discussed some diagram. Uh, some diagram was there and some factors were there, and we tried to generate the CPTs for all the scenarios. For scenario one, some causes were there. So here some sequence, some symptoms were there in the phases one and two, and here you were having some. The patient was having something, some disease was there, and then here you were having some X-ray kind of a thing, and here we were having shortness in breathiness. And so here some factor was there, if you can recall, was there, and these were the example we discussed in the regarding the patient. If the patient is having some symptoms, and what conclusions can be done based upon this generating the probabilistic values. So Bayesian networks is all about concluding some values based upon this probability theory, and also it also uses this directed graphs basically, right? And for all these four scenarios, that is this pollution, smoking, and shortness in breathiness and X-rays, we basically try to compute here the CPTs. If you might remember, we generated the tables here for CPTs, and we tried to compute the probabilities of having cancer with respect to this factor, pollution with respect to this, smokeness factor with respect to this, with respect to this, X-rays. So we that is what we are discussing. That is when we are generating the CPTs. If the node has too many parents, now in this node, that is the cancer node, it has these two parents. That is the pollution thing and this smoking thing. These two are the parents. In case these the node has too many parents, then the chances of getting this CPT tables, it becomes very large. I mean, a lot of values will be generated for each of the parent, and you try to consider all of the parents, and then you try to compute the probabilistic values for the given factor. So that is there in the Bayesian networks. That is, in case of CPTs, they can become very large. That is, the node can have, if the node can have many parents, or the parents can have, if the parents have got too many values. When this comes into the picture, that is the Markov property is there. We use this in combination with, along with in Bayesian networks, in order to arrive at the conclusions in various technologies. Now, what this Markov property is basically, what it says is, it says that there are no direct dependencies in the system being modeled which are not already explicitly shown via the arcs. What we are trying to say here is, uh, this was about this uh, CPTs. What we are trying to discuss in here is, you have these different nodes, node 1 to this, then this, then this. So here we were having this pollution factor. Here we have this smoking factor. Here we have this cancer node. And here we are having this X-rays, and here we were having that disease that was dyspnea. That is shortness in breathiness. That is what was there, and we were having this flow of information among these nodes. That is, uh, we have the flow like this, from this way. From this, the flow is like this, and from this, the flow is like this. Fine. Now, now from the diagram, you might be observing that the information is flowing like this. From the first two nodes, it is like this, and from this node, the information is flowing like this. Fine. Now, what we are basically trying to say here is, that is, smoking is basically influencing this disease of breathiness only through causing cancer. Fine. But we are the influence thing is, that is, this smoking basically it is causing this cancer, and if this thing happens, if this extreme disease happens in the patient, then the patient can also feel this shortness in breathiness. Fine. So what we are trying to say is, that is, this shortness in breathiness, it is happening through through one of the causes of smoking, but through the cancer. That is, there is a node direct link is there between these two nodes. That is, ये जो direct link की जो हम बात कर रहे हैं, that is not there. Cross में है. It doesn't exist. This link is not there. That is, the direct link is not there between this smoking and this disease that is dyspnea. That is shortness in breathiness. It is happening it is happening as one of the causes can be smoking, but it is happening through the cancer. That is what we are trying to say. That is, there are no direct dependencies in the system being modeled which are not already explicitly shown via arcs. इसमें डायग्राम में आप देख रहे होंगे, यहाँ पे डायरेक्ट डिपेंडेंसीज नहीं है इसमें, स्मोकिंग और इसमें डिस्नोया में, ठीक है. डिपेंडेंसी है स्मोकिंग और इसमें कैंसर में, then there is an arc between this cancer and this disease, ठीक है. So this whole thing is basically happening like this, ठीक है, from this to this and then this to this. नोट डायरेक्ट इसमें जो है जो डिपेंडेंसीज है नोड्स में, that is not there, that is not there. So that is what the Markov property is all about. There are no direct dependencies in the system being modeled which are not already explicitly shown via arcs. Fine. And Bayesian networks which have the Markov property, they are also called independence maps, or you can say I-maps. Bayesian networks which have a Markov property are also called independence maps, since every independence is suggested by the lack of an arc is real in the system. Okay. So this is basically, we can refer to this diagram as an I map or independence map for short. जो भी Bayesian networks जिसमें Markov property हम find out कर सकते हैं, that to that basically we can refer to that Bayesian network as an independence map also. Fine. And while doing this, while modeling this kind of a system, हमारी जो कोशिश ये होती है कि we try to prefer minimal models and in particular minimal IMAPs, ठीक है, such that deletion of any arc, it violates the IMAPness by implying a non-existence independence in the system. So that is what we try to do have is we basically prefer minimum models and in particular minimal IMAPs, fine, such that deletion of any arc, it violates the IMAPness by implying a non-existent independence in the system. And every arc in the Bayes networks, they happens to correspond to a direct dependence in the system. Then the Bayesian network is said to be a dependence map. अगर हर एक आर्क उसमें Bayesian network में correspond करती है to the direct dependence, then उस network को we can basically refer to that as a dependence map. One is independence map, that is there is no direct relation between the two nodes. One is the node is happening due to cause of the intermediate node from the source node. And if the other case is also there, that is if every arc in the Bayesian network happens to correspond to a direct independence in the system, then the Bayesian network is basically said to be a dependence map. Fine. इसमें इस पोर्शन में बेसिकली जो आपकी मार्कov प्रॉपर्टी है वो होल्ड नहीं कर पा रही, ठीक है। तो बेसिक नेटवर्क्स के हम दोनों ही केसेस को कंसिडर कर रहे हैं with IMAPs also, in the situations when IMAP are also existing in the Bayesian networks, and also the Bayesian networks in which the direct this correspondence is there between the nodes, right? और वो Bayesian network जिसमें दोनों आपके IMAP भी हैं और ये dependence map भी हैं, that is basically said to be a perfect map. So that is a Bayesian network which is both an IMAP and a dependence map, that is DMAP. It is basically said to be a perfect map, fine. ये इस डायग्राम में जैसे ये जो हमने डायग्राम कंसीडर किया था इंडिपेंडेंस में, अगर स्मोकिंग कोज कर रही है कैंसर को एंड देन फ्रॉम द कैंसर दिस shortness in breathiness is there, then that is kind of independence map is there. और वही अगर हम इसकी अगर हम बात करें, अगर हमारे पास डायरेक्ट लिंक भी दिया हुआ है कि that is smoking also directly causes this dyspnea, then this will be basically referred to as a dependence map. अगर ये हमारा this relationship is also there, direct relationship is also there, that is if you have the statement like smoking is also causing this dyspnea, then it will be basically referred to as a D map, that is dependence map. And the whole diagram is basically having consisting both independence maps and dependence maps. It is basically referred to as a perfect map. It is basically referred to as a perfect map. That is what we have discussed here this in our process till now. Fine. That is what we have discussed here in this text for our this Bayesian networks. And now next comes the reasoning part. That is your reasoning part. What is this is? That is how to basically how to use the Bayesian networks, you can say, to reason about any given domain. Okay, reasoning यही है ना, how we can reach the inferences, how we can come to some conclusions by using the approach. यहाँ पे हम Bayesian approach use कर रहे हैं. So how reasoning is how you are using the Bayesian networks to reason about the given domain. ठीक है? So here we are basically discussing the reasoning with Bayesian networks. Fine. What is there in this is that is the basic task for any probabilistic inference system is to compute the posterior probability distribution over for a set of variables given the new information about some evidence variables. Hello. हाँ जी मॉर्निंग सर मैं डिपार्टमेंट से हूँ नहीं उतने 309 सी हाँ जी हाँ बी 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 सो दैट इज रीजनिंग बेसिकली क्या है हमें ये जो हमारा डायग्राम है यहाँ पे हमारे पास अलग अलग नोड जो है वेरिएबल्स दिए हुए हैं ठीक है तो यहाँ पे हमने बेसिकली हमारे पास अलग अलग वेरिएबल्स होंगे फॉर एग्जांपल यहाँ पे हमारे पास कुछ एविडेंस होएगा हो सकता है कि हमारे पास गिवन है कि द पेशेंट इज अ स्मोकर तो वो ये जो स्मोकिंग फैक्टर है वो एविडेंस है हमारे पास ठीक है उस गिवन एविडेंस से आप फर्दर आप किस तरह का डायग्नोस्टिक आप इंफॉर्मेशन आप कंक्लूड कर सकते हैं आपका फ्लो ऑफ इंफॉर्मेशन विद रिस्पेक्ट टू द नेटवर्क किस डायरेक्शन में हो रहा है so that is all about the reasoning how you can conclude the inferences or how you can arrive at the conclusions by the different reasoning methods so that is what we are discussing here in this text that is the basic task for any probabilistic inference system is that is to compute the posterior probability distribution for a set of query variables query variables हम कौन से कह सकते हैं कि इस डायग्राम में आपका क्वेरी वेरिएबल्स इट माइट बी दिस पोल्यूशन इट माइट बी अ क्वेरी वेरिएबल ठीक है ये आपका एविडेंस हो सकता है स्मोकिंग एंड यू माइट बी ट्राइंग टू डिटरमाइन द वैल्यू ऑफ दिस query variable whether the pollution might also be the factor in causing this disease to the patient so that is what is all about the reasoning that we can do with the help of this Bayesian networks and with this Markov property. Fine. So that is when we observe the value of some variables, we would like to condition upon the new information. अगर हमारे पास कोई variables की value यहाँ पे given है इस diagram में अगर इसकी value हमारे पास given है या इसकी वैल्यू हमारे पास कुछ गिवन है तो उसके साथ हम कौन सी कंडीशंस जो हैं हम एसोसिएट करके विद रिस्पेक्ट टू द न्यू इंफॉर्मेशन एसोसिएट करके हम कौन सी न्यू जो वैल्यूज हैं वो हम ऑब्जर्व कर सकते हैं ठीक है दिस इज आल्सो बेसिकली रेफर टू एज अ कंडीशनिंग और बिलीफ अपडेटिंग और इन्फ्रेंस दिस इज आल्सो बेसिकली referred to as an inference or it is belief updating fine or it is also referred to as a conditioning thing fine so we'll see the different types of reasoning that can exist in this scenario basically so we have the different kinds of reasoning and what are those different kinds we will try to see here. That is we have basically the four different categories of reasoning here. One is here is diagnostic reasoning and then here you have the predictive reasoning then this is your causal reasoning and this is your combined reasoning fine so Bayesian networks में we have this different categories of reasoning, and what happens, what can be the query variables, what are the different variables which are there in these different reasoning sections. We will be basically seeing that. Fine.
automatic printing service ਆਪਣੀ ਹੋਣਾ ਡਿਊਟੀ ਹਾਂ ਓਕੇ ਜੀ ਤੇ ਕਦੋਂ ਫ੍ਰੀ ਹੋ ਤੁਸੀਂ ਬਾਹਰ ਲੈਕਚਰ ਤੋਂ ਬਾਅਦ ਇਹ ਤੋਂ ਬਾਅਦ ਮੇਰਾ ਲੈਕਚਰ ਆਪਾਂ ਫਿਰ 12 ਮਿੰਟ ਬਾਅਦ ਮਿਲੀ ਹਾਂ ਚਲੋ ਠੀਕ ਹੈ ਚਲੋ
Thank you. So let me show some diagrams here. Diagrams are there. This one. Let me show some. So I hope this text is visible to everyone. Is it visible? The text which I have just written. Is it visible to the class?
Yes, sir.
Okay, so this is like this. This is upward. The direction is upward here. This way. This is the direction of reasoning. This direction of reasoning. Now, the first reasoning work we are discussing is diagnostic reasoning. Now, these are the same nodes are there. That is, the P here stands for pollution thing, S is for smoking, C is the cancer, and X is for the X-ray report, and D is for this dyspnea. Fine. And what happens here in this is, in this reasoning, it is basically from symptoms to cause, as when the doctor, now here evidence, we are given this evidence, that is dyspnoea is there with the patient, fine. Now from this evidence, that the doctor, it basically, it will try to this go upward in the direction, that is whether this symptom, whether for this symptom the cause is the cancer, or the cause is and if the cause is cancer, then what further the cause may be for this cancer to happen, whether the cause is smoking, or the cause is pollution. So that is from the given evidence, it tries to identify the causes, basically, that is in the upward direction. So the reasoning here, you might be observing in this case, the reasoning is happening in the upward direction, the opposite direction, right? Otherwise, in general, when we have drawn this Bayesian network, we were coming from upside to downside, from causes towards symptoms. Now here we are given this evidence, that is this shortness in breathiness, or dyspnoea, as our evidence, and from this evidence, we are basically trying to determine its cause, that is in the upward direction, whether the cause is what can be the value for this, uh, the probability of happening this cancer, when you are given this evidence in the form of dyspnoea, and what can be the probability of having the patient, यहाँ पे हमें patient तो दिया ही हुआ है कि the patient is whether the patient is smoker or not, ठीक है. तो upward direction में हम basically जो है हम follow up कर रहे हैं, when we are given the evidence in such kind of this Bayesian network. So that is the diagnostic reasoning, that is from symptoms to cause you are trying to go towards. Okay? That is when the doctor observes this dyspnoea and then updates its belief about the cancer. So यहाँ पे updates its belief about the cancer is, it tries to determine the probabilistic value about this cancer node, and whether the patient is a smoker, or the patient is 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 living in some polluted environment, that probabilistic values you are basically trying to determine in this kind of a diagnostic reasoning, right? Fine. And then next is your this one, that is the predictive reasoning. I'll again go for the diagram. What happens here, and this is the same diagram is there. You have this as a patient, you have this as a smoking thing, and this is the cancer thing, and x-rays, and this is the dyspnoea thing, fine. And now here, let us suppose the evidence is lying here. This is our evidence, that is that the patient is a smoker, fine. So now where the query will be, the query will be here, and the query will also be here. Also the query will be here. Fine. Now here in this case, in this predictive reasoning, what we are given is, just a second, let me complete it. Okay, complete the diagram. This way, this way. No, oops, that has gone wrong. This is not like this. So this is like this, then this, then this, then this, then this. Now in this, what is here happening here in this is reasoning from new information about causes to new beliefs about the effects. For example, patient may tell his physician that he is a smoker. Then the physician knows this will increase the chances of patient having cancer. So here what is happening here in this is evidence is given in the form of this information, that is the patient is a smoker, and from this the physician, it will try to predict the probability of having the cancer for that patient, what can be the probability, and further what can be the chances of the patient having having shortness in breathiness and having the positive X-ray reports, giving the positive report about the cancer. So in this you have basically the direction of reasoning. It is same as it was there in the original Bayesian network. That is, the direction of information flow is like this, from top to down. It is flowing. That is, here in the top we are given the evidence, and then when we are going downwards, we are trying to determine the probabilities for these different node variables. Query is acting at this the cancer variable. Query is also there at this X-ray variable, and query is also there at this Bisnoya variable. Fine, and this is the evidence is there given with us. So that is what happens in the predictive reasoning. That is, you try to predict something when some evidence is there with you. Fine. And next is, third one is the causal reasoning is there. That is causal reasoning is there. Now what is there in this? Same diagram is there. So here we have this. Is there. Now these are the same variables that we have used in the previous scenarios. diagram, it remains the same. Yes. Now, intercausal reasoning has basically to do with this. That is, assume that in this case, you are given this evidence that the patient is basically smoker. Fine. Now, given this one piece of evidence, what you are basically you can conclude from this is that is being a smoker, it is going to um, it is going to increase the chances of getting the patient having cancer will be more, and this factor, that is the pollution factor, it will be basically non-effective. That is, you are basically trying to the alternative reason, that is alternative reason, it might be this, the pollution might be there into the picture. But once you get this kind of an evidence that is the patient is a smoker, then the other alternative, basically you are basically going away from the other alternative that is possible in that given scenario. So that is the intercausal reasoning is there, and same in this also. The direction of reasoning is from upside down, that is from top to down approach. Fine. And the combined reasoning is when all these three scenarios you try to combine into the given Bayesian network with the given Bayesian network, you try to combine all these three reasonings, then you can basically conclude that uh, these three, this diagnostic also, and you have this predictive reasoning also, and you have this intercausal reasoning also. By using all these three different reasoning procedures, you try to basically, with the help of given evidence, you try to arrive at some given conclusion, or you try to come at some given conclusion with the help of this given inference procedures. So these are basically your inference procedures. Now you're trying to reason with the given domain knowledge, and you have the different methods or different approaches of dealing with those different scenarios, you can say. We were discussing in the Bayesian networks the different types of reasonings are there. So how you can basically reason with the given domain in the Bayesian networks. So one is a reasoning approach you can apply is, that is the diagnostic reasoning from down towards top. That is, from the given evidence you try to determine the causes which can be there responsible for the given evidence, or from the given symptoms you try to determine the cause for the given effects. And then there is the predictive reasoning, that is going from top to down. From the given piece of evidence you try to go downwards, and then you try to update the information about the new beliefs given whatever the piece of evidence is there in the given Bayesian network. Then intercausal reasoning has to do with going away from one alternate cause given another cause which is instrumental in determining the value for the given cause, basically. That is, this piece of information is more instrumental in determining the value for this piece of factor. And the combined reasoning is you employ all these reasoning methods, and then you try to basically come at the conclusions given your different inference procedures. So that is the basics about the different reasonings that you can deploy in the Bayesian networks, and how you can reason about the given domain. Fine. So talking about the summary, if we can discuss, summary is we basically discussed this Markov property. And why we discussed that? Because we saw that in Bayesian networks there was conditional probability tables that were there, and in that basically if the nodes they have too many parents, then the CPTs or the conditional probability tables they would have gone so large, and you can say overlap with that, we can use the Markov property in our Bayesian networks. And what is that? If there are no direct dependencies are there in the system which we are trying to model, then that is the good show of an Markov property. And these are also basically referred to as an independence maps, and the ones which have the dependence maps in the given system which we are trying to model, those are said to be the dependence maps. And the Bayesian network, which consists of both this independence maps and dependence maps, they are basically referred to as a perfect map. And then we discussed about the various how we can use the Bayesian networks to reason with the given domains. So that is there the summary regarding the today's session. If anyone having any doubts, you can ask or you can post your queries in the chat message.